What's up guys, welcome to today's presentation. We are going to be talking about comets and asteroids. Joining me are my classmates Griffin, Iran, Reese, Theo, and Tom. My name is Anthony, and today I'll be kicking things off by giving you a general overview of comets and asteroids. So, without further ado, let's get into it. So, to begin, let's talk about asteroids. What are they, and where do they come from? Commonly referred to as space rocks, asteroids are rocky bodies that revolve around the sun like planets. However, due to their small size, they're often too small to be labeled as planets, or even dwarf planets. Asteroids are composed of materials such as oxygen, silicon, nickel, and iron, which give them their rocky or metallic nature. Asteroids are as old as the solar system itself. As the solar system was taking shape around 4.5 billion years ago, most of the gases and dust within fused together to form planets and moons. However, not all of this material was fused together. The debris that was left over formed into small chunks of rocks in space known today as asteroids. Unlike planets, asteroids do not possess atmospheres due to their small size. However, some asteroids are known to have smaller moons revolving around them. Asteroids come in many different shapes and sizes, and the majority of them reside in a region of the solar system known as the asteroid belt. The asteroid belt is a donut-shaped ring made up of asteroids located approximately 2 to 4 astronomical units away from the sun in between the orbital paths of Mars and Jupiter. The total mass of the asteroid belt is around 4% of the mass of Earth's moon. Approximately half of that mass is occupied by the 4 largest known asteroids: Pallas, Vesta, Hygiea, and Ceres. Ceres is the largest known asteroid in the solar system. It currently resides within the asteroid belt and has a diameter of over 444 kilometers. In fact, Ceres is so large that its gravity shapes it into a sphere, much like planets and moons. Because of its abnormally massive size for an asteroid and its spherical shape, some astronomers actually believe Ceres to be an inner dwarf planet. Now let's talk about comets. Comets have some very interesting and unique properties, often referred to as cosmic snowballs. Comets are balls of ice, dust, and frozen gases that orbit the sun. When comets are frozen and condensed, they're roughly the size of towns and small cities. However, when a comet's orbit brings them close enough to the sun, they heat up and spew dust and gases into space. This makes them emit a glowing head and tail, which gives them their iconic bright tail appearance from here on Earth. A comet's tail is always pointed away from the sun, no matter its velocity. A comet's tail is often longer than the diameter of most planets and can extend up to millions of miles. When it comes to their origins, in the year 1959, an astronomer by the name of Gerard Kuiper discovered that located beyond planet Neptune was an icy disc-like belt that orbited the sun. This was believed to be the home of many comets. This region is now known as the Kuiper Belt. It is believed that the Kuiper Belt orbits within the vicinity of the orbital path of Pluto. However, the Kuiper Belt is not believed to be the home of the majority of comets. This title belongs to a far-out region of the solar system known as the Oort cloud. Unproven and first theorized by an astronomer by the name of Jan Oort, it's believed that the Oort cloud is a region of space occupied by small debris that encompasses the entire solar system like a sphere. It's believed that this is where the majority of comets originate from. It's also believed that the Oort cloud orbits the sun at a distance of 100,000 astronomical units, with its innermost parts orbiting at around 30,000 to 50,000 AU. To put that into perspective, Pluto's elliptical orbit gets closest to the sun at only around 30 astronomical units. This also means that the Oort cloud orbits the sun 100,000 times farther than Earth's orbit is to the sun. The outer edges of the Oort cloud are about 1/4 to half the distance to the nearest neighboring star. Not much is known about the Oort cloud as it remains to be proven. However, the Oort cloud is thought to house over 1 trillion small objects which, when their orbit brings them close enough to the sun, heat up, spew gases, and become comets. No man-made object has ever reached the distance the Oort cloud is theoretically located at, or will anytime soon. 2 of the farthest traveled spacecraft from Earth, Voyagers 1 and 2, will die out centuries before they even arrive at the inner edges of the Oort cloud.
Hello everyone, I'm Joshua Donaldson and I will be discussing asteroid classification. Over the years, many different taxonomic systems have existed for asteroid classification, dating back to 1973 with Chapman, Morrison, and Zellner's initial taxonomic system all the way up to our modern SMAS, or Small Main Belt Asteroid Spectroscopic Survey, taxonomy. Regardless of the system, however, all asteroids are classified visually through use of albedo analysis, surface spectrum analysis, and, rarely, density analysis. Albedo analysis and surface spectrum analysis are often used in tandem to first determine the reflectivity of an asteroid, and then analyze the color of the reflected light to determine what may comprise the surface of said asteroid. Density analysis is used very sparingly as it requires specific criteria to be used. In general, there are 3 main groups of asteroid classification, with numerous subcategories under each. The main categories are C asteroids, S asteroids, and M asteroids, or X-types as they are also known. The most common asteroids are the C asteroids, or chondrite asteroids, which are mainly made of clay and other carbon-based materials. Of the different asteroid types, C asteroids are the dullest, appearing dull gray to black on the albedo spectrum, and actually make up a large portion of the known asteroids. Additionally, C asteroids are also most likely to have water in or on them, and may be responsible for some of the water we have here on Earth. The second most common asteroid is the S-type, which are primarily comprised of silicates such as olivine and pyroxene. Due to this, S asteroids appear fairly bright on the albedo spectrum and give off greenish to reddish light, with pyroxene giving off reddish light at about the 2 micrometer wavelength, while olivine only gives off green light at the 1 micrometer wavelength. The least common and least studied asteroid type is the M, or metallic asteroids, which are largely comprised of nickel or iron. These asteroids often exist as pure samples of their comprising metals, and due to this appear reddish as their metals oxidize. The most significant M-type asteroid is the 16 Psyche, which is around 200 kilometers in diameter and possesses unique qualities which give cadence to it originating as the core of a protoplanet, or one of the planetary bodies that originated shortly after the Big Bang. Other than composition, asteroids are also categorized by their location. Most asteroids are located in the main asteroid belt, with M asteroids scattered throughout, C asteroids generally on the outside, and S asteroids generally on the inside. However, some move on more intersolar pathways such as NEAs, which are near-Earth asteroids, one of which is theorized to be what wiped out the dinosaurs, or Trojans, which follow in the path of Jupiter. Overall, though, most asteroids stay fairly clustered to those which share similar composition, and these clusters are referred to as families, such as the Hygeia family derived from the 10 Hygeia asteroid.
Next, we'll speak about the birth of asteroids. It all started 4.6 billion years ago, at the beginning of the formation of our solar system. When Jupiter was born, not allowing any secondary bodies from forming in between Mars and Jupiter itself, that event led to the small objects that were there to crash against each other, separated into space, becoming the asteroids we know of today. These asteroids come in all shapes and sizes. For example, we have the Ceres asteroid, which is as big as 583 miles and can be as small as 6 feet wide, being the smallest asteroid ever recorded, named 2015 TC25. Interesting name, right? Next, we have the Chicxulub asteroid, which is known to have wiped out most of the dinosaur existence. The Chicxulub asteroid was an asteroid of 11 to 81 kilometers, 7 to 50 miles in the diameter, and having a mass between 1.0 times 10 to the 15th power and 4.6 times 10 to the 17th power kilograms, which struck Earth at the velocity of roughly 20 kilometers per second, which is pretty fast. Next, we have the birth of the comets. Just like asteroids, comets were born 4.8 billion years ago when space was covered in dust particles plus gas particles, which can be said to look like the picture to the right. These dust particles then stick together to form a rock. These rocks then collide with other rocks, forming what is known as a comet. These comets consist of ices such as water, carbon dioxide, ammonia, and methane mixed with dust. Although comets can still die from passing near the sun too many times, which is said to be around 500 times. As the comet passes near the sun, the dust particles and water particles tend to boil up and leave the comet, as they leave a tail of dust particles. Comets are very small in comparison to asteroids. Their average diameter usually ranges from 750 diameters, which is around 2,460 feet, or less, to about 20 kilometers, around 12 miles. For example, we have the Hale-Bopp comet, has a nucleus of more than 60 miles in diameter. Comet Hayatuke's tail stretched out at a distance of more than 500 kilometers from the nucleus.
Good afternoon, everyone, and I'm going to be continuing our presentation on asteroids and comets by talking about interstellar objects. Interstellar objects are astronomical objects which are not bound by a host star's gravity. This just means that they are able to freely travel through space. There are three main types. There are asteroids, comets, and rogue planets. Nomenclature was denoted by the International Astronomical Unit. They initially thought that it was a comet, so they named it after the comet nomenclature. They then discovered it wasn't a comet and named it after the asteroid nomenclature, but it wasn't until that we did finally discover that this was not from our host solar system that we denoted it with the I, simply as interstellar. The first one ever discovered was Oumuamua. It was discovered October 9th, 2017 by the Pan-STARRS telescope. It is a Hawaiian word meaning a messenger from afar arriving first. It is believed to have come from the inner regions of the solar system in which it originated from. This is due to it having a similar composition of D-type asteroids found in our own asteroid belt here locally. How we know that it's an interstellar object? Well, we know that from its eccentricity. So with an eccentricity value of 1.199, it's the highest ever discovered in our system. With the value greater than 1, that means that the object exceeds the sun's escape velocity and has a hyperbolic orbit. With a velocity of 26 kilometers per second, it would not have been able to obtain those speeds if it had originated within our solar system, so it would have had to have come from outside. The second one discovered was Borisov. And what makes this one unique is that it was the first interstellar rogue comet ever discovered. It was discovered August 30th, 2019 by Gennady Borisov. It is not like Oumuamua in that, it's a comet. So it is, the composition is uncommon. It's mostly depleted in water and C2 or diatomic carbon, but contains large amounts of CO, carbon monoxide, and 8H2 amines, which give it its blue hue for its tail. The comet is actually 14 sizes larger than the Earth. And that's from tip to tail. So the actual nucleus of the comet is only half a kilometer, which is still very large. Borisov has an eccentricity value of 3.36 and has a heliocentric orbit and has a velocity of 32 kilometers per second. On March 12th, 2020, observational evidence was discovered of an ongoing nucleus fragmentation, which just means that basically the comet started breaking apart when it got too close to the sun. And astronomers observed a piece being ejected towards the sun. They were able to observe this piece until April 6, 2020, when it finally disappeared. So those are interstellar objects. They're really interesting just because they're not from our system, and they're basically aliens. So they have all kinds of information that we're not used to, and it would be really interesting to study them and find more about them. Thank you.
Hello, my name is Griffin Hansen. Comets are observable from the naked eye, and the disturbance in the night sky has shocked many civilizations playing a role in history. Seen as a sign from the gods, many people soon feared the event and deemed it as a bad omen. First recorded by Chinese astronomers, they documented a comet that looked like a star resembling a sword and considered it a symbol of change. Astronomers making many discoveries and the mass acknowledgement of the heliocentric theory led to the first proper identification of Halley's Comet. The first predicted comet was done by Edmund Halley. Published in his Synopsis of the Astronomy of Comets in 1705, comet sightings in 1456, 1531, 1607, and 1682 were so similar that Halley said it was the same comet returning to Earth every 75 years. He died before seeing it return in 1758, but on Christmas night it arrived as predicted, so that next year was named after him in his honor. Halley's Comet is one of the most popular comets. It returned in 1910, which was visible to the naked eye, and for the first time, it was photographed. This was important because the trend about comets continued. Camille Flammarion claimed that the gas trailing the comet after being analyzed as toxic would fall to the Earth, and I quote, would impregnate the atmosphere and possibly snuff out all life on the planet. This was obviously not true, but still brought people to a panic. They bought gas masks, anti-comet pills, and anti-comet umbrellas while boarding up their homes until after the shower, at which time they swallowed something a little bit more than pride. Comets and asteroids orbit our star between the known planets in the three main areas of our solar system: the asteroid belt, the Kuiper belt, and the Oort cloud. Comets and asteroids both have been accepted into a certain category of space definitions called small solar bodies. They are pieces of material that orbit a star but are too small to qualify as a planet or dwarf planet. The difference between solar bodies and dwarf planets are size and their position orbiting the Sun. Dwarf planets are a celestial body with a direct orbit around the Sun that is massive, enough to be controlled by its gravitation, but unlike a planet, it has not cleared its orbital path. Similar to planets, though, asteroids often orbit in the same direction, but with much smaller elliptical paths. It contains elements commonly found in the universe like carbon, nitrogen, hydrogen, and oxygen, along with other compounds and silicates. The main difference between asteroids and comets is the composition. A comet is relatively small, yet an icy object composed of water, carbon dioxide, ammonia, and methane gas. The dust that holds the particles together along its trip around the Sun contains oxygen, hydrogen, carbon, nitrogen, silica, and various other metals.
Hey everybody, I'm Theo McCrae, and I'm going to be talking a bit more about Ceres, the troubled history Ceres has had when it's come to its classification, and how it's challenged the way that the astronomy community classifies celestial objects. At different points in time, Ceres has been classified as a comet, a planet, and as an asteroid, in addition to a few other minor classifications. Ceres was first spotted by Giuseppe Piazzi in 1801. The name Ceres is in reference to the Roman goddess of agriculture. The proposed name for Ceres originally was Serere Ferdinandia, Serere being Italian for Ceres, and Ferdinandia in reference to King Ferdinand of Sicily, but the scientific community dropped the last part and just went with Ceres, probably to avoid mixing in politics. Ceres was originally thought to be a comet. This was only due to the fact that Ceres appeared to be an orbital ball of light, as well as exhibiting comet-like qualities, such as appearing to have a coma at times. It was later discovered that Ceres is approximately 25% ice, and this coma effect was due to outgassing. The same year of its discovery, Ceres was reclassified to a planet based on its orbital pattern around the Sun, the main qualifying trait to be labeled as a planet at the time. It was suspected that Ceres was the missing planet that was calculated to be between Mars and Jupiter. Starting in about 1802, so about a year later, multiple other planet-like objects were found to be in the same orbital path as Ceres. This prompted the push for another reclassification of Ceres as well as other objects in the orbital path. This time, to a new classification system that would fit the guidelines more along the lines of a naturally occurring object, which is smaller than a planet and is not a comet that orbits a star. The term asteroid was coined by William Herschel at this time, but it wasn't until about 1863 that astronomers fully accepted the term. This means that, for about half a century or so, Ceres was taught in schools as being the fifth planet from the Sun, a story similarly shared later on by Pluto, with it being the ninth. Designator 1 Ceres became the first recognized asteroid, and the region that housed the asteroids became known as the asteroid belt. To throw in another layer of complexity and confusion to Ceres history, in 2006, Ceres was given the classifications of both dwarf planet and main belt comet. Main belt comet was renamed to active asteroid to avoid confusing comet and asteroid and to add another layer of distinction. An active asteroid is simply an asteroid that exhibits some comet-like visual characteristics, namely mass loss in some way or having the appearance of a coma or tail, but retains the orbit of an asteroid which is within the inner planets, not one of the longer asteroids that comets tend to have, theoretically coming from the Oort cloud. It is important to know that these classifications are on top of it already being classified as an asteroid, so Ceres is technically both an asteroid and a dwarf planet. It's also referred to sometimes as a planetoid and a minor planet, and both those terms are interchangeable with the term asteroid. Ceres is both the largest known asteroid and the largest object in the asteroid belt, making up an estimated 25% of the total mass in the area. Ceres also became the first dwarf planet to be visited by spacecraft when it entered Dawn or Dawn entered its orbit in 2015.
So, what are some missions we've had, and what have we found out so far? I'll tell you about two missions: NASA's Dawn spacecraft and European Space Agency's Rosetta probe. NASA's Dawn spacecraft left for asteroid Vespa in the year 2007 and arrived at Vespa in 2011. It took it 4 years to get there, and it traveled 2.5 billion kilometers. The craters on Vespa helped determine that planetesimals were born big rather than being made of smaller blocks of dust and rock. We also found that asteroids with less water cooled slower, giving drier asteroids like Vespa a metallic core and a rockier surface. Asteroids closer to the Sun have a composition of primarily carbon, and since we're carbon beings, this helps with the fact that they might have started life on Earth. European Space Agency's Rosetta probe set out for Comet 67P. It left in the year 2004 and made contact with Comet 67P in 2014. It took it 10 years to get there, and it traveled 43 million kilometers. Comet 67 contains phosphorus and other organic compounds, which aids the theory that comets like Comet 67P supplied Earth with some of the ingredients of life a long time ago. The comet's water supply contained more deuterium than Earth's water, which rules out any comets from past Neptune as sources for Earth's water. Have you ever wondered what a comet smells like? Well, after purposefully crashing onto the surface of Comet 67P, Rosetta found that the surface contained ammonia, hydrogen cyanide, and hydrogen sulfide. All of these compounds together would make Comet 67P smell like urine, almonds, and rotten eggs. We might not know everything about comets and asteroids, but seeking out new information helps us advance our spacebound capabilities and our knowledge of space in general. Studying the origin of comets and asteroids leads us to the origin of our planet and the entire solar system. They map out the history of every interaction made within our solar system, creating a story that we can follow all the way back to the beginning of it. Understanding how our solar system was created is a feat in and of itself, but it could lead to new discoveries on the creation of life and even to validating the history of the universe. And that's it. Thank you for listening, and have a stellar rest of your day.